Module 1, Introduction to Cloud Computing. This foundational module introduces you to the vast and dynamic world of cloud computing. It begins by explaining what cloud computing is, how it originated, and why it has become a pivotal technology in modern IT infrastructure and business operations. The module explores essential characteristics, service models, deployment strategies, benefits, and challenges to set a solid groundwork for understanding cloud ecosystems. 1. What is cloud computing? Cloud computing is the practice of using a network of remote servers hosted on the internet to store, manage, and process data, rather than relying on local servers or personal computers. It enables on-demand access to a shared pool of configurable computing resources, such as servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort. This approach transforms IT from a capital-intensive, hardware-centric model into a flexible, service-oriented model. Users pay only for the resources they consume, similar to utility services like electricity or water. 2. History and evolution of cloud computing. Cloud computing's roots trace back to the 1950s and 1960s with the concept of time-sharing on mainframes. However, the term and modern concept gained momentum in the 2000s with the advent of virtualization technology and broadband internet. Mainframe and time-sharing era. Early computing involved expensive, centralized mainframes shared by multiple users via terminals. Virtualization enabled multiple virtual machines to run on a single physical server, increasing efficiency. Grid computing and utility computing, distributed computing projects that laid the groundwork for cloud concepts. Modern cloud era, launch of Amazon Web Services, AWS. In 2006, popularized infrastructure as a service, IaaS, triggering widespread adoption. 3 key characteristics of cloud computing. Cloud computing distinguishes itself by several core attributes. On-demand self-service. Users can automatically provision computing capabilities as needed without human interaction with the service provider. Broad network access. Services are available over the network and accessed through standard devices, laptops, smartphones, tablets. Resource pooling. Providers' computing resources are pooled to serve multiple consumers using a multi-tenant model, dynamically assigning resources according to demand. Rapid elasticity. Capabilities can be elastically provisioned and released, scaling rapidly outward or inward to meet changing demands. Measured service. Resource usage is monitored, controlled, and reported, providing transparency and enabling a pay-per-use model. For cloud service models. Cloud computing offers different service models depending on the level of control and management users want. Infrastructure as a service. IaaS provides virtualized computing resources over the internet. Users manage operating systems, applications, and data while the provider manages hardware. Examples: AWS EC2, Microsoft Azure VMs. Platform as a service. PaaS provides a platform allowing customers to develop, run, and manage applications without handling underlying infrastructure. Examples: Google App Engine, Heroku. Software as a service. SaaS provides access to software applications hosted on the cloud. Users access software via browsers without installation. Examples: Google Workspace, Salesforce. 5 cloud deployment models. Understanding deployment models is key to selecting the right cloud strategy. Public cloud. Services offered over the public internet, available to anyone, managed by third-party providers. Cost-effective, but with shared infrastructure. Private cloud. Cloud infrastructure operated solely for a single organization, either managed internally or by a third party, offering enhanced security and control. Hybrid cloud combines public and private clouds, allowing data and applications to be shared between them, balancing flexibility and control. Community cloud, shared infrastructure for specific communities with common concerns, security, compliance. 6. Benefits of cloud computing. Organizations adopt cloud computing for numerous benefits, including cost efficiency, reduced capital expenditure on hardware and software, operational costs are optimized, scalability and flexibility, easily scale resources up or down based on demand, accessibility, access resources and applications from anywhere with internet connectivity, business continuity, cloud providers offer backup, disaster recovery, and data replication services, faster time to market, rapid provisioning accelerates project deployment and innovation. 7. Challenges and risks. Despite its advantages, cloud computing presents challenges. Security and privacy. Data stored off-site can be vulnerable to breaches or unauthorized access. Compliance. Meeting regulatory standards for data handling across jurisdictions. Downtime and reliability. Dependence on internet connectivity and provider uptime. Vendor lock-in. Difficulties switching providers due to incompatible technologies or data migration issues. Latency. Network delays can affect real-time applications. 8. Real-world applications. Cloud computing impacts various industries by enabling healthcare, secure patient data storage, telemedicine, and big data analytics. Finance, fraud detection, trading platforms, and risk management. Retail, e-commerce platforms, inventory management, and personalized marketing. Government, digital public services, data transparency, and collaboration. Education, online learning platforms, virtual labs, and scalable resources. That will be it for this module. Take the quiz to continue to the next module. I look forward to congratulating you upon completion of this course.